Good morning, class. Welcome back to AET 830, Internet of Things and Industrial Applications. In the last unit, we talked about asset management and industrial automation by using the Internet of Things technologies. For this section, we will look into smart grid and commercial building automation. Actually, these two topics are a little bit related because one part of the commercial building automation is to make best use of the electricity, which is related to smart grid. So with that being said, the content of this unit is quite straightforward. So we'll talk about smart grid first. For smart grid, we will move from the smart metering, which is a small area of the smart grid, and then we move to the whole house by talking about the smart house, and then we move wider into the smart grid city. And in the second part of this class, we'll look into the commercial building automation. So after introducing some basic requirements and characteristics of building automation, we'll look into a case study, especially its two phases. So we will see what we can do at the current phase 1, and what we will be able to do in the near future in phase 2. The corresponding reading in the textbook of this unit is Chapter 12 and Chapter 13. Now let's begin with smart grid. So smart grid is related to the electricity system. Basically nowadays, we basically cannot live. We may be able to live, but we may not live well without electricity. So maybe you already noticed there is a resolution underway in the electricity system. So for the electricity system, it has remained largely unchanged for more than 100 years. So basically, the resolution is the introduction of information and communication technologies into the different aspects of this electricity infrastructure. So intelligent network devices are emerging, whose Internet of Things interactions create new possibilities in the monitoring and management of the energy grids. So we use the word grid here. It is because the grid basically means if you look at a fishing net, so you see there are many grids there. The reason why we use grid to describe electricity system because nowadays many management works of the electricity is conducted by separating the areas into different grids, and the management of the grids, is conducted. So that's why the infrastructure will say electricity grid. By introducing the IoT technologies, we improve the monitoring and management of the electricity grid. So we are moving towards something called smart grid, which highlights the sophisticated bi-directional. What do we mean by bidirectional? So for the National Institute of Standards and Technology, so it defines a framework with 7 domains. So generation, transmission, distribution, customers, operations, and markets. So basically it covers how the electricity is generated and be used by different people. And for the IEEE, IEEE is Institute of Electrical and electronic. So it views smart grid as a large system of systems. So defined in the previous chapter, in the previous slide, contains 3 functional layers: the power and energy layer, the communication layer, and the IT computer layer. We can illustration in the next slide here. So this illustrates the future ICT empowered interaction with smart grid. Basically, we know the users, the current users can also be the producer of the electricity, and also information will play an important role in interaction. So let's see what is happening. For the smart grid, it is featured by the creation of the energy markets. So as well as the subsequent operation context, they will permanently change the structures associated with the production and distribution of energy. So the regulation and regulation of the energy market is designed to break up the value-added chain. So, with production, transfer, and distribution of electricity power forming separate segments. So nowadays, for most of the areas, so the electricity is produced by the nation, by a specific company, for example, the Duke Energy, and the transfer and the distribution are all handled by the same company most of the way. And for the regulation, basically, you want to break up this value-added chain. Also, it will bring about more open market to promote increased competition and flexibility of consumers. So a much more decentralized and diverse energy production system will emerge as a result. So currently, most of the energy comes from the large companies, right? Maybe they use the solar power, maybe they use the fire plant. Are they still using it? Maybe not. But in the future, we'll have biomass, solar energy, and wind power. Basically, there are different players in the system. So that brings about a new field actor here. The share of decentralized generated power produced by industrial or private producers will increase significantly. So, for example, if you have a solar panel on your house, you are actually one of the electricity producer. So, at this moment, you may think that, okay, the energy you produce is by using the solar panel in your house will be used by you, right? This is quite true for now, but in the future, it is also possible that the electricity generated by you will not be used by you. So that comes into a new phenomenon. So there will be a new infrastructure where the future user may not be a simple passive consumer as today, but they are also a producer. So in that case, it is a prosumer. Okay, this is a new term you may never heard of. Prosumer means that you're using and producing. So with that in mind, because we have many entities producing energy in the future, the integration of small, highly distributed energy production sources and their coupling with advanced information-driven services will give rise to a new infrastructure, which is called Internet of Energy. So basically now you can say Internet of basically anything, right? Internet of Energy is built based on Internet of Things, of course, and Internet of Services. So that IoT and iOS makes possible diverse interaction locally and over the internet. So IoT basically it provides monitoring and control capability, and based on that, different types of services can be provided, right? Based on the monitoring and control. And if they are put on the cloud together, so they form the Internet of Services. So it provides the fine-grained monitoring and control of large energy infrastructure. So an illustration of the relationship between IoT, iOS, and IoE is illustrated here. Basically, Internet of Energy is an emerging domain for IoT plus iOS. The resulting Internet of Energy is the vision of smart grid. Okay, basically, when we talk about Internet of something, that means that for example, Internet of Energy, that means the energy is provided as a service, and then it can be accessible from somewhere you may not know and you don't need to know. The smart grid is one of the key areas where the economic benefits of monitoring and control are likely to be realized. So, for example, it is driven by the degree of decentralization of system components, be driven by the variety of new renewable generation. Nowadays, we have many wind power and solar power generators. It is driven by increased distance between electricity generation and consumption, increase the intelligence level and the level of work. With different degrees of maturity related to smart grid value chain, we look into several of them. First of all, for the smart grid, we need to look at it from the network viewpoint because of the complexity of the multiple smart grid stakeholders interaction at different layers. So it is expected in such a network, all distributed energy producers and consumers will be highly interconnected via information flow. So in that sense, a paradigm changes from the existing passive and poor to active information-rich energy networks. Let me explain a little bit. So for now, well, the electricity system is kind of passive, right? Basically, you just receive the power, electricity from the cables, from wires. And maybe you don't know, basically the price of the electricity actually is changing during the day. Maybe you don't pay attention to that. But as I mentioned, maybe because you don't know about it, because no one tells you about it. So it is information and illustration or information poor. So but in the future, there will be the paradigm will be active. Basically, there will be interactions between you and the energy producer, as well as many services providers, and also information rich will enable this. In some future state, in the future, it will be the service-oriented infrastructure we talked about in the last unit, and also there will be bidirectional information change, be the basis for cooperation among the different entities. We'll have some examples showing how the directional information is happening. So this is a reading for you to illustrate that. What I want to highlight here is that their capability of offering fine-grained information devices energy signature as well as control capabilities describe a shift towards a high observable controllable infrastructure. So what it means is that in the future, for example, if you have a fridge or refrigerator in your house, services can monitor, energy management system can monitor the usage of electricity on that fridge and develop the fridge's energy signature. Basically, it can figure out when the fridge is using more power, when it is using less, and can happen in a day. It can also happen in a relatively long time, maybe a week or maybe a year, so that it can expect how much energy is to be provided to this fridge, for example, during the year. On the other hand, the energy management system or the services may also be able to control, although it is not a good idea, it may not sound like a good idea for now, so that it can function in a more cost-effective way while making sure that everything inside your fridge will not go bad. So that's the bidirectional interaction. So during this process, apart from the traditional IoT aspects, so of particular interest is the customer, operations, markets, and service provider domains. Basically, we have more actors in this. Previously, it's only you and the energy provider, Duke Energy, for example. But now it is enabled by the data available. So we have many other players. Okay, now let's look at. So that's an overview of the future trend energy system. So now let's look at some components of the energy system. Let's begin with the metering. Metering basically measures how much energy is used in your house. For example, traditional utility management process involves the collection of meter data from a centralized point in the household once or twice a year. A month, I think. Right. Basically, you receive your electricity bill every month, right? With the emergence of smart metering, of data from households has increased. Maybe it is 15 minutes intervals or even shorter. This coupling of smart meters to an infrastructure that can monitor at such a fine-grained form the electricity formation and consumption of resident households has profound implications for the grid itself, as well as value-added services, if coupled with other tools such as IoT data analytics. So in other words, so because now we have more data about the usage of the electricity in your house, we can do more things. So for example, we can know what time during you're using more energy, right? So this information may be helpful to you, and also it may be helpful to so that they can allocate more electricity to you or to the residential during the day. Many utility providers today strive towards offering new energy services that enable customers to better grasp their energy consumption by seeing the amount of energy they consume in short intervals. So if you go to Duke Energy website, I think you can see it, maybe daily data. I'm not sure whether they provide hourly data now. The aim is to move towards 1 minute resolution. Basically, you see how much electricity you use every minute, and coupled with variable tariffs. This may produce consumer a view on the upcoming costs and assist end users to adjusting their energy consumption behavior. So actually, this kind of, for example, you know how much you need to pay in the future. If it is going too high, for example, in the summer, some people just put the AC to a very low temperature, and then they will be shocked when they see the bill. And also, some people are trying to reduce the carbon footage in their life. So this information will help them to change their consumer behavior. For this scenario, key IoT aspects such as integration, remote monitoring, remote management, and real-time analytics are needed. And for the next slide, it describes the paradigm change from an infrastructure delivering meter data for billing purposes towards a general purpose monitoring infrastructure, including multiple users and value-added services. The key here is the data. The data generated includes not only the energy metering data, also data, which may provide additional value towards asset management. So let's look here. So for today, okay, so we just do metering for what? For billing, right? How much energy you use. In the future, we'll still do this, but also for example, some devices will be directly connected to the service provider. For example, the manufacturer of the fridge or the washing machine, so that they can know how their products are functioning in your house. So that will help to provide some future optimization opportunities for your fridge, right? And also that can help them to adjust the function of your fridge or your washing machine. And also that can provide some kind of maintenance help assistance. For example, if they monitor that your washing machine is taking extra electricity during the operation, that may malfunctioning of the washing machine. And if you have electricity cars, vehicles, electricity usage data can also help different functions offered by the manufacturer of the vehicles. Basically, the key difference here is that the electricity usage of the devices, they can provide us. And some of the services now are still being explored. But just now, I already mentioned some examples. For example, they can optimize the functioning and design of the washing machines. They can do some evaluation of the performance and function of the washing machine, for example. And there should be many other services that can be provided. So it's just in your imagination. The new smart meters and also their extensions can be used as communication media, where the utilities push information, for example, about their current energy tariff, upcoming maintenance, and costs will be provided. Soft control of the infrastructure, and the users will shift apart from their activities to non-critical times. They notice that if they use the If they use the washing machine now, they need to pay more. On a similar train of thought, lowering the price implies shifting energy consumption to those intervals where the energy is available, but not enough consumption is present, for example. So it will result in a financial-driven energy management. So basically, you will still live in the good life standard, but with some changes in your life behavior. For example, will you take a shower? For example, at what time would you like to take a shower in the day? So yeah, some of you in the morning, some of you in the evening. You may be able to figure out which will be better for you to help to save the electricity cost. And also cook, yeah, I think cooking can be more set for the time, right? Morning, noon. But the showering is just an example of possible lifestyle change based on the energy. IoT is a key to this bi-directional communication between the utilities and their customers. It is expected that 200 million electricity smart meters will be deployed in Europe by 2020, last year. It's 72% of the European company. So smart metering will benefit for all the involved stakeholders. Research. So installing of the smart meter is $205, but it can provide savings of $309 for 1 year. So there are benefits.